Okay, so we're going to walk through the setup first. Going to insert a new component and need to find the part. So basically a block with a couple of tapped holes and a drilled hole. One of the okay, so from the education version, so one of the issues is going to be we're going to set up the mates. And even if I could reach through this hole, do I want to drill through or make it part of the index? Right. So the issue with drilling all the way through, there may be times where we have to, but we're going to try and minimize that as much as possible. So I don't think I set this up completely for this part, but just like we would do with a standard vise, I want the fixed jaw to be my datum reference. And then whatever I need to adjust, oversize, well, that's not too bad. There's a little bit of a gap there. That'll be the difference, opening and closing the vise jaw. Or we'd go ahead and cut that just a little deeper since I missed. All right, so in the 246 class, we went ahead and we cut out these pockets, and we're getting to this point of setting up to run the pieces. So let me go ahead and pull these out, and we'll bring in another part component and run through the mate. And don't want the edge. So coincident. And really we want to make this as user-friendly as possible. So when I'm setting this up to close the vise, really want to push that against the face with a minimal amount that it can come forward. This is assuming that we've already made it to done some pre-machining to size, or that our stock is enough oversized that we're going to be able to set it up. Let's see, what did I grab there? All right, we'll try one more time. All right, not going to give me the coincident. Okay, so that looks okay. Double check what I put in there. So coincident, coincident, and then the back face and coincident. All right, so they're in the same orientation. They're going to be using the same tooling. And let's go with part 1, part 2. I need the temporary axes. Okay. All right, so through the center, I'm going to be able to find a temporary axis. And then also, I guess I need to get out of the habit of going directly to the temporary axis and see if we'll rotate around the face first. All right, so those two, and I need to find my circular component pattern. Rotation is about the center, and we're going to end up with 4 instances. Okay. Now let's go ahead and save. I'm in the process of locking up there. We'll go ahead and turn master cam on. And okay, so one of the issues again is that when we're setting up for any kind of fourth axis operation on a rotary, tombstone, otherwise, is really can we rotate this part and have enough clearance on the bottom side? Right. So if I go to the end, there was in the rotary, I believe anyway, there was a surface, and the surface body is hidden. So I built this surface body so it'd kind of go through the process. If I saw anything sticking out here, anywhere through the rotation, then this part would come around and contact the base. And pretty much that would be the end of that program. We'd have to do something different, cut the jaws deeper, do something to manage that geometry. All right, so that's one of the quick checks: is do I have enough to rotate? The next is, how do I want to manage my my orientation? So when we did the block, which I still have to catch up on, when we did the block, is we put the origin at the nose. Depending on the setup, if I'm accurate enough on the setup, machine the jaws in place, then I could potentially put the origin at the center of the nose of the tombstone, and then all of this would be related to back to that geometry. What that doesn't do is give me individual control over each of those setups. Another decision: am I going to machine the top and then have a another work coordinate for the sides and another work coordinate for the opposite side? I can post out for just that geometry and call it as a macro, so that I put the rotations into a macro and I'm not reproducing every line of code throughout the whole mix. So basically sub-programming it. Right, so we have those different levels to work from. All right, so based on what we're able to do, we have the mill default. That's not going to get us where we need to go. So under the files, we're going to replace the mill default with, we have the generic cause 4th axis mill. Watch out for the MMs, and we'll pull that one in as well. And the machine control, make sure that all of those match. And then from a tool, we'll go to program 1, start in increments, and then the stock setup. There again is, I'd like to have the whole block, but how do I get that material and then make it reasonable on the simulation? So let's go with upper corner. Oh, not in the bounding box yet. So we'll select the corners, and let's see, select other. No. And not going to be able to see the opposite corners. So let's see. Nope, not going to work there. I can't select through. Well, can't select anything while Mastercam is active. All right. Well, bounding box gets everything. I really don't want to machine that much, but we'll go ahead and pick it out. And it was showing up in metric. Oh, we're still in metric. So, oops. And that's what we get from the tablet, inch, pounds, and seconds. Let's go ahead and hide some of the miscellaneous items. What's that? Tab. Hover over top of the part and hit tab, and it'll go away. Shift tab will bring it back, but you still have to come over to the feature tree to make sure that everything's back on. All right, so select corners. We'll go side to side, hit OK. The display's on, and it's not showing me my corners. Double check. Okay. All right, so we'll at least be able to see the two. All right, so Shift Tab. Let's at least bring back the soft jaw, maybe, or most of it. All right, so setting up the coordinate. The origin is showing as the center bottom of the block. We manage this in a couple of different ways. If the material is oversized and we're doing first operations, we could put a tooling ball at the center of the fixed jaw. That would get us a repeatable location. The other option is that I'm going to have to do an edge find on each of these locations, which means that I'm going to have to set up a plane for each of the parts in their orientation. So under the plane manager, we can go in and pick geometry, and this will be well, let's kind of abbreviate it, part 1 and top, and we'll go with the 2 lines only. So that sets up for the X and Z, and reverse the direction. Alright, and then we'll go for new geometry, part 2. So one of the advantages of the orientation, no, I don't want to rotate. I want you to pick, and pick, and then reverse the direction. So that is the part 2 top. And then more geometry, we're going to end up with an edge and an edge. And that one's okay. So this is part 1 front. Okay, so that one's okay. So part 2 front, and I wasn't leaving spaces, so stay consistent with that. And then we got to get back around to where I can see the 2 on the back side. So geometry, part 1 back. Okay, and we'll reverse. No. Try again. Alright, so X and Y and Z in the correct location. New geometry, part 2. On the back. And set those up, reverse the direction, that should be okay. All right, so what this is going to do is I pick through these different planes and setups. I'm going to have duplicate operations. Well, we can't copy, but as long as I pick those up, I'm going to be able to reproduce the operations from part 1 to part 2. So in effect, what we're doing is making these independent of the rotary. Now that's going to make it as precise as I can get it. All right, the other thing is, back to that whole subprogram thing, we're going to have one complete operation. Going to be able to jump through, and it may be a thing where I would post out for toolpath group to be 1, and then the back would be 2, and then 3, so that I could have those as separate items to work from. So you manage this the way that it makes sense, the way that it kind of will follow your logic, or the company logic is the way they like to do their programs. All right, so if I go that route, then I'm going to end up with 2 pockets, 2 drills, and I'm not going to worry about face operations. I said that for this setup, we're just going to have the one the block of stocks already to size. We're not doing any sizing, facing, and running the perimeter. So let's go into the operation, mill toolpath. I set the origin to current. and we're going to go with the pocket. All right, double check with the chain that everything's internal. And probably need a better name than that, but okay. Half-inch ball end mill. I don't know why it's defaulting to that one now, but let's go into the filter, make sure none's selected. Okay, there it was. And then going to pick up for the, looking right at it, half-inch flat. All right, and then the rigidity of the machine. Oh, one of the buttons I didn't check was to assign numbers sequentially. So tool number, length offset 1. Surface feet per minute, let's go up around, oops, too much. Yeah, 50,000. Yeah, that's a bad. That's one mean machine to have that much spindle. All right, so well, let's look at 1200. All right, so we're close. Half-inch. Let's just run it at 9,000. We'll be somewhere in between. Feed per tooth. Drop it to 1,000. 36 inches a minute is quick, but it doesn't seem out of line. I might be able to go faster. Probably should go slower. All right, so rapid. This is going to be part 1 on the top. Cutting parameters, climb, pocket type, standard. We're going to go back to the no material, roughing. Let's stay with, so these are all of our 2.5 axis operations, except we're looking at it in the context of where this is in position with that part. All right, so since I did not go to the center of the part, my 0, 0 is still at the top corner. So I shouldn't have anything, really extreme positive numbers coming out of the linking parameters. So if we did a parallel spiral, I still like the high speed. Step over percentage, 50% max, spiral inside to out. Entry motion, helix in. And the finishing, one finish pass, start at the closest vicinity and keep the tool down. So it won't do a full retract, it'll allow it to do the feed in. 100% on the length, that's a little bit on the large side, so 10%. A little bit on the low side. So we're going to stay with the 0.1s. Send those over. Depth of cut. Well, we didn't. We told they could do 50%. So the issue is usually that if I use a large step over, I can't get as much depth. And with the rigidity, the overhang of the rotary, I don't want to go too crazy with it until we kind of figure out where this is going to fall out. So on the step over amount, we did 50% step over. I want to say that this was 3/4 or 1 inch that we were cutting down to. So I wouldn't have a problem using that much end mill. My problem would be on the step over distance that is going to be too much radial engagement for that much axial engagement. Right, so we've got to kind of find that happy spot. So I think initially I want to take this in one depth and then go to the 50 thousandths. Could look at doing the trochoidal cut, but not entirely sure that I want high speed, the high speed machining going on either. So the high speed has the easy transitions, so that's pretty much why I picked it for its for the type. No breakthrough. Depth is incremental. Top of stock, absolute. Feed plane. Like to have a little bit more if we have the clearance. And then for our planes, we'll just double check. We're at P1 top all the way across. All right, so what did I miss? Speed, feed, do a quick double check. See what we get. All right, so feeds in, and would prefer the spiral to be at the front, because this first full width, full depth, that kind of defeats the whole purpose of what I was trying to do with the high speed. You know, pretty much one of two things is going to happen. Either we have enough RPM and it's going to make that ½ inch of travel at full width, full depth of the tool, but at 36 inches a minute, we're probably going to weld up the tool and break the tool, or spit the part out of the vise. Once we spit one part out of the vise, since these are pulling against each other on a double vise, then this one's pretty much going to get loose, and even though it's not going to come flying out, maybe like this one did, this one's going to have the same type of issue.
So would that be that closest entity? Closest entity?
No, I think on the finish pass, well, we can turn the finish off and regenerate it, and it's still going to enter at the same location. So since we didn't give it a what I'm trying to say,
no one.
What's that?
That one. The entry motion one.
Set for the helix.
I thought there was one that said closest, enter closest entity.
What I did on the finish was to just bring it over wherever the last pass was, bring it over to the wall at the closest entity. Now there's not you haven't really set an entry point. Let's see if center on entry point. Yeah, it's really not moving it over. Let's see if we can find it. And definitely don't want to plunge. So the start finish pass at closest entity is wherever the last pocket pass is. That's where I'll pick it up. Pocket type. No. All right, so that being the case, let's go ahead with trochoidal cuts into the full material only, and see if that kind of skews it to one side. So loop radius 100 thousandths, loop spacing 100 thousandths. See what we get. Pocket step over distance causes excessive tool engagement. Loop step over is greater than. Okay. Yeah, I did that. I told it 50 thousandths. See if it barks at that. All right. So, oops, jump back into it, regenerate. All right, so the thing with the trochoidal cuts is once it gets in, it's going to start those small loops. And there's different methods. Different programs have ways of dealing with that engagement. All right, so let's go ahead and set up the next one. Back into the plane manager. We'll set everything equal to P2 on the top. And my parameters then insert the next pocket. Got button happy. All right, so we're here. Let's go ahead and take a look at it. It's interesting that it leaves a tower and then it comes back and knocks the tower off. All right, so yeah, still not sold on the trochoidal cuts or the pocket. So what I need to do is go back and find the entry position, but we'll see if it magically appears on the next one. All right, mill tool pass. Setting up for the pocket. I wasn't editing that one to pick that up again. No, I guess not. Didn't have anything selected, so that was kind of weird. Double check real quick, yeah. Part 2 on the top. Have the same tool, same RPM feed rates. Alright, helix, follow the boundary, and centering on the entry point now. Okay, so there's that was what I was missing, was the Oh, that's still on the finish. That's not on the roughing. Is looking at the entry point, but we haven't set an entry point yet. And the entry point needs to be at the center of the pocket. So I'm not sure why it's picking up that outside corner. So the other thing that I would look for is, do we have a wall clearance? All right, so the XY clearance, so maybe that's the one I'm looking for. So it moves it a little closer to the center. It would be at least be offset, so I'd buy that. See if it can calculate it at 3/4. All right, so that moves it far enough off the wall clearance. Don't really like doing it that way, but I'm not finding another another setting that's going to give me anything better.
Does it really make a difference?
Well, what I'm trying to avoid at all possible cost is to be almost an inch deep with a 1/2 inch end mill and have the first pass be a 1/2 inch wide. All right, if it's doing the helical ramp and we have material, the material's allowed, it's pretty much being ejected as we're following that helix, and it gets into that first pass and tries to move through. That is going to be a heavy load. We're reducing, we're trying to reduce it as much as possible, and even though the end mill could possibly eject those chips, I would still want to. Oh, and that was kind of the other thing as I'm talking, I just realized, is the other thing on that helix then is we're allowing it to go 50% and up to 100%. Well, that's a pretty sizable amount. You saw the tower that it was leaving in the center. I really don't want that tower either. So minimum radius, I'd be happy with 50 thousandths minimum radius, and a maximum radius of, well, the radius of the tool is 1/4 inch, so it'd be spinning around a center. So let's see what 250 looks like. All right, so basically what it says is I have this open pocket, and if I can spin an inch, it'll leave the tower. So it can spin 1/4 inch, it'll spin around that center. Oh, I keep expecting it to automatically regenerate. All right, so comparing the two, kind of side by side, much tighter, but now I'm having to change the offset again, or the back to the wall. All right, so let's look at the entry motion. We did 0.05 as a minimum and 0.25 as the maximum. And let's see what 1 1/4 looks like getting in. So basically same process. We're going to refine this as we go. So I'm going to go at the center, and this may get it to where I don't need the trochoidal cuts as much. So let's go ahead and turn those off and see if it makes the transition a little cleaner. All right. So basically going in a loop and a spiral going to the next level. That looks reasonable, and I'm almost centered. That's a desired result. All right, so parameters. Roughing, we'll turn off the trochoidal, go back to the entry motion, XY clearance of 1 1/4, and OK. So pretty much I'm back to relying on what I see on the screen in these toolpaths. That's what I'm expecting the tool to do once it gets to the machine. All right, so these were 1/4 tapped holes, and this is the point I have to decide, do I want to manage these out of toolpath groups? So all of the toolpaths that are going on at the top, and we're doing singles to keep this on the simple side, to get you into the thought process, not necessarily the full-blown program. If I'm running a 1/2 inch tool for the facing operation and then pocketing it out, I'm not engaging a tool change. If there were 1/4-20s in the corners, then I would want to consider the toolpath group is all of the tools that I would be running in that setup, so that it minimizes the tool change. All right, so we're not going to see it verify on the sides. Go into the plane manager, P1 front, set everything equal, work and tool. And to set up the new toolpath group, I'm going to go back to the machine group and with it active, and then say new toolpath group. All right, so this is going to make it so that if I need to, I can post one set of program, post the next set of the program, and then call those as subprograms out of kind of a master program. All right, so we're going to go into the toolpath, set up for the drill, and I'm going to go to the bottom side. And check the points. All right, so the tool is going to be a drill bit. Let's see here. Chamfer, drill. And for a quarter 20, we're looking for a 201. So number 7. And they got the rounding thing going on, so that's interesting. Oh, and still I forgot to go back and change, so we're going to have to modify that up manually. High-speed steel going into aluminum, 200 surface feet per minute, 3,800. 36 is a little aggressive on that one, but probably not too far off. We'll slow it down just a touch. And I don't think I did that on the other one, but got the caps on front. All right, cut parameters. We're going to do the PEC drill, or possibly in this case the chip break, the high-speed steel, or the high-speed pecking routine. And PEC, yeah, 100 thousandths isn't too far out. All right, so linking parameters. And let's see, incremental top of stock is showing at 5.54. Now let's go incremental and pick. So top of stock, quarter inch. Would think that would be 0 in relation to the planes. So we're at, no, it jumped back. No, P1 front. Yeah, that was it.
Wouldn't that be P3 and 4?
No, well, those were parts 1. Yeah, actually, well, just as far as position 1, position 2. Maybe I should say position 1. Okay, so it is in the front, and the origin is at its location. Yeah, I would expect that to be 0, even on the incremental. All right, let's see what we run into when we try to simulate. Now the other, well, no. And then the depth being incremental. And quarter inch wall thickness. Temp comp on. And home reference points, home position. Yeah, it all looks good. So toolpath looks okay. I'd like to see what code it generates for when it calls. You know, in this maybe that's what I overlooked. Got into setting them up, and it is going to automatic work offsets. It may require that I set this as G54, 55, 56, 57, 58, 59. Since I haven't done that or hard-coded the work offset, the automatic may or may not be doing what I expect it to do. All right, so that'd be something to check. We're just going through process, so I'm not that concerned when I'm looking at the code, getting ready to go out and run this on the machine. I'm going to be a lot more strategic about my decisions. All right, so we got the peck drill. Tool comes over, speeds and feeds are the same. Cut parameters. Yeah, so we're still going to peck the 100 thousandths, linking, tip comps on, double check the planes, and didn't swap that over. So let's shift to P2. And shift to P2. Okay, so those look pretty good. All right, and then for the operation, since I'm already over here, we're going to stay in. Well, let me go ahead and make sure that I'm selected. All right, so for P2, we'll go ahead into the tapping routine. And the issue is that I need tool holders and extensions that not only can reach, because the spindle is going to be, let's go to this side. The spindle is going to be up here. And we're going to have the tool holder. We're going to have whatever projection gauge length on the tool holder, and then whatever we're putting in for the tool length. And we have to be able to clear all of that on length to get to past the soft jaw and then still have enough clearance. So if we're using an ER16 tool holder, then the drill and the tool holder still has to be able to clear, in the worst case, the top of, basically the top of that jaw. All right, so as we're working through that process, those are some things that we want to check. All right, so when we get into this this level, or getting at this this strategy, this would be a good time to. We're going to go back into the drill, select the same 3 holes. All right, so bottom for depth, double check the points, go ahead and accept. And we've been jumping over the tool holders, but we have. Let's see, we need the taps, right-handed tap. We'll pick up for the quarter 20 and accept. Oh, and still didn't turn on the assign tools. All right, we've been jumping over the holder, and one of the things that I'd want to check is, pretty much for size, what these values work out to. So if I assign a relative tool holder, or find out where this library came from, or make my own, then I could double check for tool projection, and we'd want to make sure that we had a tool holder, the nut on an ER16 relative size, and this projection large enough that when we go to verify this, it has a reasonable looking for the collision. Yeah.
Maybe after you're done with the video, can you show us how to import tools?
Oh, bring in the tool that you've drawn? Yeah. Yeah, we'll set that up in the library. Okay. So cutting the cut parameters, we are not pecking, we are tapping. Linking parameters. Now in that that tool selection, just real quick. Didn't set the spindle speed. So typically what I'd say is I would just add the 0 on the end of that, so I get the 10 inches per minute. So it is calculating correctly. I don't need to go too crazy. I've had going for the impressing. You can tap at 1,000 RPM, but why? Typically what I do is on the newer Haas controls, and on the newer controls you have a retract speed multiplier. That is very handy. I like that, but I don't want to get too crazy. So what this ends up working out to for surface feet per minute is a fraction of what we can cut with the high-speed steel, but we're still relying on the spindle being synced with the Z travel, and you're putting a lot of expectation into those two components always working correctly. So at the higher RPM, it has to reverse faster. You're dumping all of that energy from 1,000 RPM into the regenerative braking. It has to start, go into the tap, stop, reverse, go back to 1,000 RPM, and come back out. All right, so the slower speeds is not going to hurt my feelings. It's still going to be 10 inches per minute. Let's see, linking parameters. We're going to go a little bit deeper, and so for the tip comp, we'll add a little bit more. Breakthrough amount of maybe 100 thousandths so that it does tap, does all the way through. All right, and then double check that we're in the correct plane. All right, so clearance-wise, this is our retract. It's going to come up that far and move over to the next part. So if I'm not entirely sure that I have 100 thousandths repeatability between those two parts, I'm going to increase that by a little bit, especially with the tapping routine. I'll need to span that out, get back into the parameters. So on the linking parameters, the retracted 100 thousandths, incremental. Yeah, 250 is probably not too bad. What I'm looking at is above that 250 and then the other 250. What I don't want is even at the tap going 10 inches per minute, it's still, what, at 250, it's 5 revolutions before the tip, and then we get into the lead. It's probably close to 7 or 8 revolutions before it ever pulls a chip. And so it's just kind of a, where do I want to find that happy spot? All right, so the first one, the retract. So probably the same with the pectorals. We go back and add those in. Pick the same group. Don't think I changed my plane manager, so we'll have to do that out of the operation. Picks up the same. I don't remember what I had for the designation. Tapping routine, link parameters, picked up everything, and then the planes. I'll go back to the P1 front. And accept. All right, so directions and my clearance. All right, so new toolpath group. And we'll say with the 3, and I believe this was just a drilled hole. So 3/8, mill toolpaths, drilling. We have the point, except I picked on the top. So let's see what the difference is in the selection. All right, so select the library tool, filter back for the drills. And a 3/8 drill, put into the mix. 200 surface feet, pretty fast again. Hey, it didn't bark at 20,000 though. And 12 inches per minute's not too far off, so we'll stay with that. Oh, thank you. Yeah, tool numbers. Cut parameters, we'll be back to pecking. And the linking parameters. So quarter inch, and we'll see what it ends up with depth. So 100 thousandths in the tip length. Planes, missed again. Double check that I actually got one. Oh, and would help to go back. There we go. Didn't want to go to the, went to the tool. Getting tired and button happy, so. Yep. Try again. All right, all three. Now the three, I think the WCS, the tool plane is the most important. So, tool pass, drill, and we'll select the top again. Everything else should still be there. Tip comp, planes. Yep. Okay, so depth-wise, other than the tip comp that we put in there, we really didn't get that same going through the part on the toolpath that we saw on the front. So since we're working in those incremental modes, the selection is that much more critical. So back into the geometry, and we can clear out. And now I'm lost. I don't remember which one I was picking. So the P1 back was the tool plane. Oh, there's my coordinate system. I'll go ahead and accept. There we go. All right, so notice the coordinate system disappeared and reappeared. There's my clue. All right, regenerate the parameters. All right. So what I would be interested in is out of the toolpath group. Let's go one more. Let's see, did it pull that in? Yeah. Let's see if we make that active. There we go, that'll work. All right, so at the insert point, mill toolpaths, what I want to try is if we can pull up, and I'm not seeing it on the side. So I'm looking for the pattern. Oh, transform. All right, so we're going to rotate about an axis. Okay. And we're going to pick both of the pockets. Method is by coordinate. Still need an axis to rotate around, so I don't think this is. It's still trying to rotate within the plane, not around the outside. Okay. So in that case, we are at that subprogram level where this will get me the first group of programs. I can call these, do a rotate, call it again, and call them in whatever order, and try to minimize the amount of tool changes. The other thing would be to go through and add the additional, and we had a tool plane, so where we stopped at 59, we'd go over to G154 P1, G154 P2, and basically cycle through each of those locations, and that's where it gets complicated. We're going to have 3 of these times 4 setups, minimum of 12 planes. All right, so I want to try and minimize that, but if I have to, I'm going to go through that entire setup. All right, so our block isn't big enough, but let's go ahead and see what it verifies. Maybe we'll see the tool moving anyway. So the pocket the drill and tap. Wow, that was quick. And then the drill on the backside. Don't blink, it's over with. Okay, maybe not. Back it up a little faster. Slow it down a little bit. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1 and 1. Okay, so the verify, even though we didn't pick it up entirely, is there. Let's see, on which one was that? Maybe it's the standalone version that has a fixture, so we could define that as the fixture. That helps in some looking for collision detection, and I'm not finding it here, so we have a few more things to look for, but again, give you the basic idea of the operation, getting it set up, preferences, making those decisions.
Okay, so the issue with the transform then has been resolved in several other videos, so I'll forego the explanations and go right to setting up the transform. We have our 2 pockets, so we can display those somewhere, I hope. Where are we picking those up at? I can see the, well, let's go ahead and pick everything, display on, display off. Having the video card issue, let's see. Well, still not picking up the preview. Well, double check that it's there with the back plot. Alright, so it's going in. Alright, so let's go ahead and set up for the transform and see if the video comes back. Alright, so transform, we're transforming toolpath group 1 and 2. It's going to be around the tool plane in operation order. And rotate. Rotate 3 instances, 90 degrees at the start, 90-degree increments. Rotation plane, we need to find one that is pointing to the side, so let's see which way that goes. Alright, so it flipped up on end. That was not the correct choice. Alright, so let's save the guessing and go to the plane manager. Let's see, if I go to the master cam front, that gives me a z-axis, master cam back, z-axis going the other way. Either of those will work. And pick the front, hit OK. Go ahead and regenerate. And switch over to the wireframe. Alright, except for we still need the axis was rotating about that face. Alright, so let's double check. Alright, so since our origin was not at the center, I need to set a location, and we'll pick the rotary back here. That ends up changing the YZ location. And let's go ahead and regenerate the dirty operation again. And I'm not sure what's happening, but I'm only seeing my toolpath as I rotate, so that is giving me the correct result. Alright, so one more time, toolpath group 2, go into the transform, make sure that everything's selected, all of our previous settings carried over. All of the previous settings carried over except for the top. Rotation plane, we want to be master cam front. Okay, it's not going to let me have either of those. It's a weird shift. interesting. Alright, so if we're in the origin, well, let me have it. No. So we have our selection. Those are strange overrides. So since it's not going to give me an orientation that I can work with, we'll go back in and create a new plane. Geometry, 2 lines. We can pick something that's in reference to. Let's call it a transform plane. Okay, so that gives me geometry, if it'll let me select that. Okay, and then regenerate. And other than floating out in space, the orientation looks okay. Oh, let's go back and make sure that we're picking the central axis. One more time, regenerate. Okay, so those look okay. And I'm not sure why it's not, why it isn't letting me pick the master cam front or back. Alright, so one more, transform. And that transform plane, it really didn't matter where I placed it. I could have put it on the rotary back here, as long as the z-axis was pointing out and away in the axis of rotation. So that will do it for the transforms.